June 26, 1944, 3 kilometers southwest of Villers-Bocage, Normandy. Oberscharführer Heinrich Schultz had been commanding Panzer IVs for 2 years. He'd fought across the steppes of Russia, through the mountains of Italy, and now in the hedgerows of France. He understood tank warfare the way a surgeon understands anatomy. You stopped, you aimed, you fired. That was doctrine. That was physics. That was survival. Through the narrow vision slit of his Panzer IV Osphir H, Schultz watched 5 American Sherman tanks advancing across an open field. They were moving fast, perhaps 25 kilometers per hour, their hulls bouncing over the uneven Norman farmland. He smiled. Moving targets were easy targets. Every tanker knew you couldn't hit anything while moving. The suspension vibration, the engine shake, the terrain variation, all made accurate gunnery impossible above walking speed. "Halt!" Schultz ordered his driver through the intercom. The Panzer IV shuddered to a stop behind a hedgerow, its long 75mm KWK-40 gun trained on the approaching Americans. Gunner, target, tank, 1,200 meters, lead Sherman. His gunner, a 19-year-old kid from Munich named Werner, peered through his telescopic sight. "Jawohl, Herr Oberscharführer, target acquired. Fire when ready." The Panzer IV rocked backward as the gun fired. Through his periscope, Schultz watched the tracer arc toward the American formation. It was a good shot. The round passed just in front of the lead Sherman, which was exactly where it should have been if the target had been stationary. But the Sherman didn't stop. None of them stopped. They kept moving at full speed, and as Schultz's loader slammed another round into the breach, something impossible happened. The lead Sherman's turret traversed smoothly, tracking Schultz's position while the tank continued bouncing across the field at 25 kilometers per hour. The gun barrel remained absolutely steady, as if mounted on a concrete pillbox rather than a moving vehicle. Then it fired. The 75mm round struck Schultz's Panzer IV at the turret ring, the weakest point in the armor. The penetration was catastrophic. The last thing Heinrich Schultz ever saw was the white-hot flash of his own ammunition cooking off. His gunner Werner survived long enough to be pulled from the burning wreck by his comrades. In the field hospital 3 hours later, before he died from his burns, he kept repeating the same phrase to anyone who would listen. "Sie haben geschossen, während sie fuhren. Sie haben uns getroffen, während sie fuhren." They shot while they were moving. They hit us while they were moving. The German doctors thought it was delirium from the trauma. It wasn't. Werner had witnessed the single most decisive technological advantage in armored warfare during World War II, an advantage so profound that most German tank crews never understood what was killing them. American Sherman tanks were equipped with a revolutionary gyroscopic stabilization system that allowed them to fire accurately while moving at full speed. German tanks, for all their superior armor and more powerful guns, had to stop completely to aim and fire. In tank warfare, the side that stops first dies first. The Germans were stopping. The Americans weren't. The impossible technology. The story begins not on a battlefield, but in a Cleveland workshop in 1937, 7 years before D-Day, 4 years before America even entered the war. The Sperry Gyroscope Company had been perfecting gyroscopic instruments since 1910. Their gyrocompasses guided ships across oceans. Their autopilots kept aircraft flying straight. But in 1937, a U.S. Army Ordnance officer named Colonel John Christmas posed a question that seemed impossible. Could a gyroscope keep a tank gun pointed at a target while the tank was moving over rough terrain? Every expert said no. The forces involved were too great. A tank gun weighed over 1,000 pounds. It moved through 2 axes, elevation and traverse. The vibrations from a moving tank were chaotic, unpredictable. Gyroscopes were delicate instruments. They couldn't possibly control something as violent as a tank gun under combat conditions. The Sperry engineers, led by a man named Ralph B. Stewart, decided to try anyway. The M4 Sherman tank that rolled off American assembly lines starting in February 1942 contained a technological marvel that weighed 160 pounds and sat in a sealed housing beneath the turret basket. The Westinghouse gyrostabilizer, officially designated the Stabilizer Gun 75mm M4. The device consisted of a spinning gyroscope wheel rotating at 14,400 revolutions per minute. This wheel maintained a fixed reference plane in space regardless of how the tank moved beneath it. When the tank pitched over uneven ground, sensors detected the deviation between the gyroscope's stable plane and the gun's actual position. These sensors fed signals to hydraulic actuators that automatically adjusted the gun's elevation to compensate. The result? A 75mm gun that remained pointed at the same spot on the horizon, regardless of whether the tank was stationary or racing across a plowed field at maximum speed. The system worked in two axes. The gyrostabilizer controlled elevation, keeping the gun level. A separate system called the power traverse allowed the turret to rotate smoothly using hydraulic power rather than manual gears. Together, these systems meant a Sherman gunner could keep his crosshairs on a target while the tank was moving at speeds up to 30 miles per hour over terrain that would shake a man's teeth loose. German tank designers knew gyroscopes existed. They used them in aircraft instruments and naval fire control, but they never attempted to install them in tanks. The engineering challenges seemed insurmountable, and their doctrine didn't require it. German armored tactics emphasized the defensive ambush. Find a position, go hull down behind cover, wait for the enemy to approach, destroy them with superior optics and more powerful guns. This doctrine worked brilliantly in Russia in 1941 and 1942, where vast open spaces allowed German tanks to engage from long range against Soviet armor that often lacked radios, optics, or proper training. It failed catastrophically against Americans who wouldn't stop moving. To understand why gun stabilization was so decisive, you need to understand the mathematics of tank gunnery. A tank gun is not a rifle. You can't just point it at something and pull the trigger. You're firing a projectile that weighs 15 pounds, travels at 2,000 feet per second, and is affected by gravity, air resistance, and the rotation of the Earth over distances exceeding 1,000 yards. Hitting a stationary target from a stationary position requires calculating range to target, angle of elevation to compensate for gravity drop, lead angle if target is moving, wind drift at longer ranges, temperature effects on propellant. Hitting a moving target from a moving position adds your own vehicle's speed and direction. The vertical and horizontal oscillation of your gun caused by suspension movement. The unpredictable jarring from rocks, holes, and terrain features. The time delay between when you see the target and when the gun actually fires. German tank gunnery doctrine, captured in training manuals from 1943, explicitly stated, accurate fire is only possible from a halted position. The tank commander will halt the vehicle, allow the suspension to settle for 3 to 5 seconds, then give the fire command. American doctrine, revised in June 1943 after North African combat experience, stated, the stabilizer permits fire while moving. Tank commanders should engage targets immediately without halting. Stopping makes your tank a stationary target. The difference in those two doctrines created a kill ratio that defied the technical specifications on paper. On paper, the German Panzer IV, with its 75mm KWK-40 gun, could penetrate a Sherman's frontal armor at 1,500 meters. The Sherman's 75mm M3 gun could only penetrate a Panzer IV's frontal armor at 800 meters. Germany had the range advantage. In practice, combat reports from Normandy showed American Shermans destroying German armor at ratios between 2-to-1 and 4-to-1 in their favor, despite the Panzer IV's technical superiority. The reason? Stabilization allowed American tanks to fire first, fire more often, and fire while maneuvering to positions where German armor was vulnerable. North Africa, the Proving Ground, November 1942. Operation Torch brought the first M4 Shermans to combat in North Africa. The 2nd Armored Division landed near Casablanca with 168 Sherman tanks, every single one equipped with gyrostabilizers. The Americans were green. Most crews had never seen combat. Their tactics were unrefined. Their coordination was poor. But they had one advantage their enemy didn't yet understand. Oberleutnant Hans Becker commanded a platoon of Panzer IV AUSF, F2S in the 10th Panzer Division. His diary, captured after his death at Kasserine Pass, contains this entry from December 12, 1942. Engaged 6 American medium tanks near Taburba. Our first shots at 1,400 meters missed as the Americans were moving at high speed. Before we could reload, the Americans returned fire while still advancing. This seemed impossible. One cannot hit a target while bouncing across terrain. Yet 3 of our 5 tanks were struck. My gunner insists the American tanks never stopped moving. Command believes this is combat stress affecting observation. Becker survived that engagement. He died 2 months later at Kasserine Pass, where the Germans won a tactical victory but noticed the same impossible American gunnery. General Hans-Jürgen von Arnim, commanding the 5th Panzer Army, filed a report on February 28, 1943. American tank gunnery demonstrates unexpected accuracy during movement. Investigate whether Americans have developed advanced optical sights or if crews have exceptional training. The report completely missed the actual cause. Von Arnim was looking for better optics or better training. He never considered that the Americans had developed a system that fundamentally changed how tank gunnery worked. The captured German intelligence assessments from North Africa, declassified in 1983, show this blind spot repeatedly. German analysts attributed American accuracy to larger ammunition expenditure, partially true. More practice time before combat, false, American crews had less training. Better optical rangefinders, false, German optics were superior. Luck, false, the pattern was consistent. Not once did German intelligence identify the gyrostabilizer as the decisive factor. They were looking for incremental improvements to known technology. They couldn't conceive that the Americans had developed something entirely new. The engineering triumph. Manufacturing a gyrostabilizer was not simple. Each unit contained 847 precision parts that had to work together in an environment that would destroy most mechanical devices. Extreme temperature variations, constant vibration, dust, moisture, and the shock of the gun firing directly above the mechanism. The Westinghouse factory in Mansfield, Ohio, employed 2,847 workers dedicated solely to stabilizer production. The manufacturing process required gyroscope wheels machined to tolerances of 0.0001 inches, bearings that could maintain 14,400 RPM for hundreds of hours without failure, hydraulic seals that wouldn't leak under pressure variations from -40 degrees Fahrenheit to 120 degrees Fahrenheit, electrical systems that could function after being shaken violently for months, sensors accurate enough to detect deviations of less than 1 degree. The cost per unit, $2,847 in 1943 dollars. That's equivalent to roughly $48,000 today. For a single stabilizer, America installed one in every single Sherman tank. Total production, 49,324 stabilizers for 49,324 Sherman tanks. Germany, by contrast, struggled to produce enough basic radios for their tanks. In 1943, they manufactured approximately 5,700 medium and heavy tanks, but only 2,000 tank radios. Many German tanks went into combat without any radio at all. The idea of spending the equivalent of a small house on a gyroscopic gun stabilizer for each tank was economically impossible for Germany. They were fighting a war of scarcity. Every pfennig spent on advanced technology was a pfennig not spent on ammunition, fuel, or more tanks. America was fighting a war of abundance. They could afford to put $48,000 stabilizers in tanks. They could afford to put radios in every tank. They could afford to give every infantry squad a semi-automatic rifle when the rest of the world was still using bolt actions. This wasn't just industrial capacity. It was a fundamental difference in how the two nations approached warfare. Germany optimized for quality. America optimized for capability multiplied by quantity. A single German Tiger tank was superior to any individual Sherman in armor, firepower, and crew protection. But America didn't build tanks to win one-on-one duels. They built systems that gave every tank advantages that accumulated across an entire battlefield. The stabilizer was a perfect example of this philosophy. It didn't make the Sherman's gun more powerful. It didn't make the armor thicker. It made every Sherman slightly more effective in every engagement, and when you multiply slightly more effective by 49,324 tanks, you get overwhelming superiority, the German failure to adapt. The most striking aspect of the stabilizer's impact is that Germany had multiple opportunities to identify, copy, or counter it, and failed every time. Captured Shermans were extensively tested at the German tank proving grounds at Kummersdorf. Technical intelligence reports from these tests, captured after the war, describe the stabilizer in detail. The Germans knew it existed. A February 1944 intelligence summary states, "The M4 medium tank contains a gyroscopic gun stabilization device that permits fire while moving. Testing confirms this system functions as designed. However, the complexity and cost of such a system makes it impractical for German production. Improved crew training and tactical doctrine should be sufficient to counter this advantage." This was staggering hubris. The Germans correctly identified the technology, confirmed it worked, then decided they could overcome it with better training and doctrine. They believed quality of crews could overcome quality of systems. They were wrong. No amount of training lets you fire accurately while bouncing across a field at 25 miles per hour. Physics doesn't care how well trained you are. The stabilizer wasn't a small advantage that skill could overcome. It was a fundamental capability gap. German tank development from 1943 to 1945 focused on bigger guns, thicker armor, and more powerful engines. The Panther, the Tiger II all followed the same philosophy. Build a tank so superior in firepower and protection that it could dominate through pure technical capability. They never considered that domination requires hitting the enemy, and hitting requires being able to fire effectively, and firing effectively while moving requires stabilization they couldn't build. The resource constraints were real. Germany, in 1943, was fighting a two-front war with strategic bombing destroying their factories. They couldn't afford to divert precision manufacturing capacity to gyroscopes when they desperately needed it for aircraft instruments, U-boat equipment, and V-weapon guidance systems. But this wasn't just a resource problem. It was a doctrinal problem. German armored doctrine from 1935 through 1945 never fundamentally adapted to the idea that tanks should fire while moving. They saw movement as a way to get to positions, not as something you did during combat. The Soviets, by contrast, immediately recognized the value of stabilization when they received Lend-Lease Shermans in 1943. Soviet tank designers attempted to develop their own stabilization systems, resulting in prototypes like the T-3485 with the STPS stabilizer in 1944. These Soviet systems were crude and unreliable compared to American stabilizers, but the Soviets understood the value enough to try. Germany never tried. They dismissed it as unnecessary complexity. The irony: the Panzer IV had better optics. The Turmzielfernrohr 5F commander's sight was excellent, better gun depression, and comparable traverse speed. From a stationary position, it was arguably a better gun platform than the Sherman. But tank battles aren't fought from stationary positions. They're fought by moving vehicles engaging other moving vehicles across terrain that's never flat or smooth. In that real environment, the Sherman's stabilization was worth more than any incremental improvement in optics or gun depression. The Soviet experience. The Soviet Union received 4,102 M4A2 Sherman tanks through Lend-Lease, all equipped with stabilizers. Soviet tankers had mixed reactions to the technology. The Red Army's armored doctrine emphasized shock attacks at close range, where T-34 superiority in numbers and armor slope would overwhelm German defenses. Stabilization offered less advantage in point-blank brawls than in medium-range engagements. However, Soviet Guards tank units that received Shermans reported significantly higher kill ratios than comparable units with T-34s. The 1st Guards Mechanized Corps, equipped with Shermans, achieved a 4.2-to-1 kill ratio against German armor in 1944-45 operations. Comparable units with T-34-85s achieved 2.8-to-1 ratios. Colonel Dmitry Loza, commander of the 46th Guards Tank Brigade, wrote extensively about the Sherman in his memoirs. On stabilization, the Americans gave us a weapon that our tanks did not possess: the ability to fire effectively while moving. Soviet doctrine emphasized movement and shock, but our tanks had to stop momentarily to fire accurately. The Sherman required no such pause. Against German defensive positions, this was invaluable. We could advance under fire, shooting as we moved, never presenting a stationary target. German tanks and anti-tank guns had to guess where we would be when their rounds arrived. Often they guessed wrong. The fascists called the Sherman the Emcha and claimed it was inferior to our T-34. But I would rather command a Sherman than any T-34 variant. The American tank gave you chances to survive that Soviet tanks did not. Soviet attempts to develop indigenous stabilization systems were hampered by the same problems Germany faced: lack of precision manufacturing capacity and competing priorities. The STPS stabilizer developed for the T-3485 in 1944 was plagued by reliability issues and never entered mass production. Post-war, the Soviet Union made stabilization a priority for tank development. The T-54/55 series incorporated increasingly sophisticated stabilization systems, a direct result of lessons learned from Lend-Lease Shermans. The British parallel path. British tank development followed a different trajectory. The British recognized the value of stabilization early, attempting to develop their own systems for the Crusader and later tanks. The result was the rotating weight stabilizer, a mechanical system that used a spinning flywheel rather than a gyroscope. It was simpler and cheaper than the American system, but also less effective. British crews who transitioned from Crusaders with RWS stabilizers to American Shermans with Westinghouse stabilizers universally preferred the American system. Captain John Stirling, a British tanker with the 1st Armored Division in Italy, described the difference. The British stabilizer was better than nothing, but it was crude. It reduced gun wobble but didn't eliminate it. You could fire on the move, but accuracy was poor beyond 400 yards. The American stabilizer was revolutionary by comparison. You could engage at 800 yards while moving and have a genuine chance of hitting. Our crews fought to get assigned to Sherman tanks rather than Cromwell's, despite the Cromwell being faster and more mobile, because the stabilizer made such a difference in combat. British military doctrine adapted faster than German doctrine to the possibilities of stabilized fire. By 1944, British armored regiments trained extensively in movement-to-contact tactics that emphasized continuous maneuver while engaging targets. The British also conducted the most rigorous testing of stabilization effectiveness. Lulworth tank ranges in Dorset were used for systematic comparison trials between stabilized and non-stabilized gunnery from 1943 to 1945. These trials confirmed what combat results suggested. Stabilization approximately doubled the effective engagement range when the firing platform was moving. A tank that could hit reliably at 800 yards from a stationary position could hit reliably at 400 yards while moving with stabilization, but only at 100 to 200 yards while moving without stabilization. Late war desperation, German last attempts. By late 1944, German commanders finally understood that American fire control systems represented a significant advantage. Several desperate attempts were made to counter or copy the technology. In November 1944, a captured M4A3 was extensively tested at Kummersdorf with specific focus on the stabilization system. German engineers disassembled the Westinghouse stabilizer and documented its design in detail. The conclusion, in a report dated December 8, 1944. The American stabilization system represents advanced engineering utilizing precision components and manufacturing techniques currently beyond German industrial capacity. Reproduction would require establishment of new gyroscope production facilities, 18 to 24 months, development of suitable hydraulic systems, 12 months, integration testing, 6 months. Estimated cost per unit would exceed 8,000 Reichsmarks. Recommendation: Germany lacks time and resources to develop equivalent systems. Focus should remain on improved armor and armament to offset American fire control advantages.